Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder how your brain makes sense of a long story or how pauses in speech help you follow along? Well, today we're diving into a fascinating study that explores just that. Imagine listening to a story, a podcast, or even just a conversation. Your brain isn't just passively receiving sounds, it is actively chopping up that stream of sound into bite-sized chunks that make sense. This process is called event segmentation. It is like putting together puzzle pieces to understand the whole picture. While scientists have studied this a lot for things we see like movies or when reading a book, much less is known about how we do it when we're just listening. And a big part of listening is prosody, which is the rhythm and intonation of speech. Think about how a longer pause can signal something important or a change in topic. This new research looks at how these pauses and the actual story content help us understand what is going on, and if older adults process this differently. So the researchers started by asking a simple but important question. Do people naturally put longer pauses between different events in a story? And do those computer voices that sound so real today do the same thing? To find out, they looked at audiobooks and podcasts. They used a fancy computer program called a large language model, often shortened to LLM, to identify where the major story events started and ended. Then they looked at the audio recordings to see how long the pauses were, right at those event boundaries compared to pauses just in the middle of events, essentially at what they call event centers. And guess what? They found that human speakers do indeed put longer pauses at those event boundaries. It's like a little verbal comma signaling a shift. What is really interesting is that modern AI voices, like the ones you hear in GPS systems or virtual assistants, also showed this same pattern. The newer AI voices were better at mimicking this human behavior of pausing at event boundaries. This suggests that these AI systems are getting pretty sophisticated, not just in sounding natural, but also in understanding narrative structure. So experiment 1 told us that longer pauses at event boundaries are a real thing both in human speech and in some pretty advanced AI speech. But knowing that speakers pause longer doesn't automatically mean listeners use those pauses to help them segment the story. That is where experiment 2 comes in. In the second experiment, researchers wanted to see if real people actually use these longer pauses to help them understand story events. They gathered 2 groups of participants, younger adults and older adults. They then had everyone listen to stories with different pause manipulations. In one version, the pauses at event boundaries were made even longer. In another version, pauses in the middle of events, the event centers, were made longer. And of course, they had an original version with normal pauses. The participants were asked to listen to these stories and press a button whenever they felt a new event had begun. It's a way to directly measure when people think an event boundary occurs. After listening, they also answered comprehension questions to make sure they were paying attention and understanding the stories. This is where it gets really interesting. The researchers found that older adults were more likely to press the button overall, meaning they tended to identify more event boundaries throughout the stories. Now for the crucial part about the pauses. When pauses were deliberately made longer at actual event boundaries, where the story was changing thematically, it didn't really help people identify those boundaries any better. This suggests that when there is a clear change in the story, like a new character appears or the setting shifts, listeners are already picking up on that thematic cue. The extra pause doesn't add much extra information. However, when they made the pauses longer at the event centers, those spots that are not real story changes, that is when things got weird, prolonging pauses in these non-event boundary spots actually made people think they were at an event boundary. It tricked their brains into signaling an event change when there wasn't one. This artificial boundary detection was stronger in people with worse hearing. This is a key finding. It shows that pauses can bias our perception of events, particularly when the story itself isn't giving us a clear signal. And this bias is even more pronounced if you have a bit of hearing loss. The researchers theorized that perhaps with hearing loss, people become more sensitive to acoustic cues like pauses, and might over-rely on them when thematic cues are weak or absent. So what does all this mean? This study powerfully tells us that while speakers and even AI are using pauses to mark story events, listeners don't always rely on them. When the story content is strong, thematic cues, those changes in characters or plot, are usually the main drivers of our understanding. However, these pauses can trick us into thinking an event has changed when it really hasn't, especially in the absence of strong thematic cues. Interestingly, the study also suggests that we might be paying more attention to the end of an event to signal that a new one is about to begin, rather than waiting for the start of the new event to confirm the change. This is a subtle but important point about how our brains anticipate narrative flow. The finding that older adults identified more event boundaries is also noteworthy. While one line of research suggests age can impair event segmentation, this study found older adults were actually more active in marking these boundaries. This could mean they have different strategies for processing narratives, or perhaps a lower threshold for what they consider an event change. This research really shines a light on the complex interplay between the words in a story and the sounds of speech. Pauses are important, but they are not the only signal and probably not the most important signal when the story itself is clear. The fact that hearing loss amplifies the effect of pauses in non-event boundary moments is a significant practical implication. It suggests that individuals with hearing loss might be more susceptible to misinterpreting speech pauses as story breaks leading to potential confusion or a less coherent understanding of narratives. This opens up avenues for future research on how to optimize auditory information delivery for those with hearing impairments. Ultimately, this study shows that our brains are remarkable at stitching together the flow of spoken narratives, using both the story content and the subtle cues of speech like pauses. It also highlights how aging and hearing can subtly change the way we process these cues. Understanding these mechanisms can help us create better audio experiences and improve our communication with diverse groups of listeners. It is a great reminder that the way we listen is an active cognitive process. Thanks for joining us on RUBIN'S Mind Lab. Don't forget to like this video, subscribe to the channel, and hit that notification bell so you don't miss our next dive into the fascinating world of the mind. See you next time!